이때까지 수염이 아름다운 남자 유승재 대표께서 사회를 밝혔는데 오늘 그분이 특별하게 강사로 오셨기 때문에 그분보다 별로 멋있지는 않지만 그래도 사회를 보게 되었습니다. 7회가 저희가 글로벌을 향하는 첫 번째 모임인데 오늘 특별한 강사분을 모셨고 전문가도 특별한 분을 모셔서 저희들이 좋은 강의를 들으려고 합니다. 생각보다 많은 분들이 와주셔서 감사하게 생각합니다. 귀한 분을 모셨는데 특별히 제가 소개하는 것보다는 비즈센터 우리 스타크래프트로 대표님이 나오셔서 소개를 해주시죠. 그리고 저희가 동시 통역도 다 준비가 되어 있으니까 너무 그렇게 부담을 안 하셔도 될 것 같습니다. 네.
좀 아까 그 인사드렸던 최종표입니다. 제가 원래 사회자가 소개해야 되는데 오늘 좀 귀한 분을 모셔가지고 직접 제가 소개하려고 나왔어요. 사실 지금 저렇게 허술해 보이지만 상당히 대단한 양반인데 한마디로 제가 이렇게 말씀드리면 돼요. 우리나라 지금 쓰고 있는 그 인터넷 도메인 네임 체계 만드는 주역이었어요. 그래서 지금 우리가 co.kr, ac.kr sorry. 아주 재치있고 직구적. 우선 저를 제가 사실 이바이타면 접니다. 근데 제가 데이콤에 있을 때 처음 만났고 데이콤의 최고 수석 CTO였고 그 당시에 94년도쯤부터 저는 일을 했던 것 같아요. 그다음 저는 이제 DI라고 국제사업 쪽에 있었고 해외 사업하는데 지금 여기는 없지만은 지금 CJ 헬로비전의 대표를 맡고 있는 김진석 대표하고 우리 셋이서 거의 삼총사처럼 우리나라 일부 한 축을 감히 만들었다고 저 인터넷 산업 일으키는데 좀 기여를 했다고 좀 평가합니다. 그 최전선에 있었고 또 그 대표적인 예로 KIDC라고 우리나라 최초의 데이터 센터 만드는 기획자이자 또 설계자로 또 기술자로 이렇게 참여를 했었던 아주 대단한 분을 제가 오늘 모셨습니다. 일단 제 개인적으로는 멘토이자 친구이자 또 어떤 때는 또 사업 파트너였기도 했었는 우리 조언인데요. 정말 이렇게 어려운 자리, 귀한 자리에 와줘서 참 고맙게 생각하고 있습니다. 저는 버클리 핵물리학 전공을 했습니다. 학부는 그리고 포항공대에 방사광 구축하러 들어와서 그러다가 지금 갑자기 인터넷으로 넘어가서 인터넷 쪽에 이 업계에 아주 마당 말인데 그리고 데이콤에서 아까 말씀드린 대로 오랫동안 기술 CTO로 있었고 그 당시 사장보다 월급이 더 많았어요. 유일한. 2000년에도 와가지고는 본인이 뉴튼 테크놀로지 파트너라는 VC를 만들어가지고 1000억짜리 펀드를 운영했었어요. 그렇게 해서 상당히 성공적으로 미국의 포스리 브리지라고 굉장히 펀드 모태 펀드 쪽으로 투자도 받고 하면서 운영을 했다. 그 당시 아주 상당히 좋은 성과를 냈고 그 이후에 또 본인이 이제 직접 잘 알고 계신 G마켓 또 G마켓 쪽 해외 투자 유치하는데 결정 기여도 했고 또 CD 네트워크스 쪽에 또 경영진을 참여해서 또 키우는데 큰 역할을 했습니다. 일단 경영 몇 가지만 들어도 화려한 그런 적이고 아주 드물게 기술과 사업적 인사이트를 갖추고 있는 그런 대단한 분이라고 제가 소개를 좀 해드리겠습니다. 지금은 핀테크 쪽에 또 새로운 사업을 개척하려고 하고 있습니다. 물론 이런 여러 가지 커리어들이 있지만 제가 가장 또 좋아하는 면은 저분이 very 리버럴한 스피릿을 가진 분이라는 것입니다. 아주 사업 이전에 인간적으로도 굉장히 친근감 있고 배울 점이 상당히 많은 이런 더 이상 소개하기보다는 오늘 강의를 들어보시고 집 명부를 한번 봐주시기 바랍니다. 또 좋은 친구가 될 수 있는 기회인 것 같습니다. Thank you. Please.
그리고 오늘 통역을 맡아주실 우리 주식회사 단자 핀테크 대표님도 같이 모시겠습니다. 뭐 이런 통역이 필요 없으시면 제가 굳이 안 부르고요.
똑같은데? 아까 보니까
필요할 때 저희가
통역이 필요 없으시죠? 여기 오신 분들 좀 그러면 다 이해를 하실 것 같아서.
My English is very easy.
그러면 통역 없이 우리가 한번 다 들어보겠습니다. 예, please.
So these days, there's so much talking about fintech. And, you know, I met a lot of fintech companies. And everybody uses fintech startup, right? So financial technology startup. So all the fintech startups have the same three things. Mostly, they don't know fin, they don't know tech, and they don't know startups. There's a lot of people jumping in, becoming instant experts. But in fact, there's a lot of activity, and you can see some results. Everybody has a mobile banking app, right? There's so much payment apps, some card scanning apps, there's point apps, all these things. The result is right now, the fintech environment in Korea is a hacker's paradise. There's no security really on any of this stuff that's out there. We've had fake mobile banking apps going on here for more than 2.5, almost 3 years. They're produced almost by a factory in China. And the losses are huge. Everybody's covering it up. The government's not talking about it, the banks are not talking about it, but the losses are there and they're large. So I wanted to talk today about some concepts behind if you're starting something new in fintech. The key point is the software and the architecture. What should we do? Next page. Oh, I can do from here. Cool. It's a pointer and a page. Okay, got it. So, the first key point is you have to design your security architecture first. This is an important point because almost everybody designs UI, and then functionality, and then some network side, and then some server side. And then finally, oh yeah, we need some security. Well, let's just patch on SSL. Yeah, now we're secure. Not. I put here common attack types. These are all real-world attacks that are happening today. The first one, very simply, is man in the middle. This is the most common. Actually, probably the most common is keyloggers, and this has been a problem for a long, long time. Every time you use internet banking, you have to add some other piece of crap plug-in to try and prevent keyloggers. But I'll go through these in a little more detail. Next page. Oh, I can do that. So the attack types, as I said, a man in the middle. Now this man in the middle can exist in the network. That's usually the easiest way to attack an SSL site, right? You have a user, you have a server. As a man in the middle, all I have to do is give you a certificate that you believe. Well, there are 200 and some certificate authorities out there. There's a lot of companies that stick extra certificates in your browser. If I can get a certificate you trust, I can now proxy your connection to that website and get everything. This is done quite a lot. The man in the middle can also be inside your device. So if you use things like antivirus software, a lot of antivirus products actually create man-in-the-middle proxies. Avira V3. Part of the software they install is actually a proxy for your HTTPS connections so that they can inspect what's inside. Well, as a hacker, all I have to do is add a little change to that software and boom, I have everything.
How about the iPhone?
V3 doesn't run on iPhone. Yeah? So it's the iPhone is a little bit better, actually quite a bit better than some other systems. If you were ranking sort of security in order in most common platforms, I would say iPhone is the best, then Mac OS, Android, Windows. Windows is really crap. Oh, I mean, there was a new hack that came out yesterday that basically any user can get around AppLocker. If you know AppLocker on Windows, which is supposed to keep a real secure environment. Well, there's some really simple tricks that you can break out of that trivially. Some security researcher reported it 2 days ago. Replay attacks are really common in network client-server protocols, where the bad guy just watches some transaction and then does it again himself. If the server's not really clever, really smart, many times this works. The data dumps, really common in PC and Android apps. You just take an image of the running program's memory, and most programmers haven't taken any precautions. I can go and find all of your private keys, your passwords, everything stored in memory there. It's actually shocking how simple this is. We all heard last year, beginning of last year, when people were worried, oh, Kakao is broken, the government can see everything. Well, of course they can. And a lot of people moved to this Telegram, right? It took me 5 minutes to hack Telegram app and dump all of the keys out of it. Yeah, their network protocol is nice and scrambled, but if I can get into your device, boom, I dumped and got everything. Their app was just crap. They've improved it now, but last year it was really horrible. Keyloggers, these are the big ones. They sit somewhere in your computer, record what you type, send it out to a bad guy. The side channel attacks are the least common amongst these. Side channel attacks are tricky, but basically it means running another program beside the program you're attacking and looking at the system response and the system timing deviations as a way to understand what it's doing and hacking the keys or passwords that way. Fake apps have been really popular in Korea, especially for mobile banking apps. This has been probably, I would say, an epidemic. There's just thousands and thousands of cases. A lot of these they're distributed through some bad MMS. User clicks the link, it installs an Android fake banking app. User presses it, looks just like the real one. He puts his username and password in, bad guy has everything. These are just shockingly easy to do, and it's stunning how many users still click on MMS links. So these are sort of the traditional things: password cracking, reverse engineering, just debugging, decompiling the code. Again, shocking how effective decompiling still is. The buffer overflow. This has been a problem we've known about for 25, 30 years, and people are still writing shit code that allows buffer overflows. This is just you gotta be careful when you're writing your code to always check boundaries on absolutely everything. And, but still, this shows up, especially if you build your code with some included library. A lot of people are using some open source library. You find a hack in there, you can insert code and run it. App infection is happening more and more these days, where the bad guy takes an existing app and finds a way to insert his own code into it. So, what do you do about all of this? So, there's a few sort of good practices, and I mention these because mostly I see it's not done here. These are, first thing is, anytime you're dealing with encryption, you have to add some random component to it. We often, in encryption cryptography, we call this a nonce, or it could be something that's different, that's randomly different every time, say, I'm sending data to you. If you say, who are you? I say, I'm John, here's my signature, and I send it. Well, if I'm sending the same message every time, the signature is the same. That some bad guy can understand that message and try to copy it. He can get information. But if I random part into this, then every time I do the encryption or the signature, it's different. You have to have random component to all cryptography. You never reuse the same key. The other thing, scramble your memory. Any program that you're running on the server or in the app, you should, for your most sensitive information, maybe you encrypt it. What we do is, so you go to store it, we store that one key, 32 bytes. We store it in 32 different locations, 1 byte at a time. And the place where we're storing it is a memory field loaded with random data. So anybody who does a memory dump sees a whole bunch of randomness. You can't extract the keys from that. It's hard to get to. Secure wipe. So anytime you use a key in your program, you use it for an operation. Now, if you're going to store it in the scrambled memory. If you're not going to store it, you have to wipe it. How do you wipe it? You overwrite it with random data, then you deallocate it. If you just deallocate the memory, that data is still sitting there in memory. You don't do a zero overwrite, because if you just overwrite with all zeros, and this is so to the programmers, a lot of people just do memset 0. So the problem with that is some compilers optimize that out, so it never even happens. Or if it does happen, the memset 0 writes zeros with other messy memory around it, so the hacker can now see those zeros and knows to look in that location for more data. You always overwrite with random data, then deallocate it. The one thing we do is we're very sensitive about what's an internal function and what's an external function. And we do this because we do everything with libraries. So in our library, we have a very limited number of external functions. All of our internal functions, we actually wrote our own tools to do this, but we scramble all of the function names, all of the class names, all of our enum names. So before compiling, we actually scramble all of those variable names. Why? It's the first thing I do when I'm hacking a program. I go in and look at all the strings. So I can see all of your text strings, I can see all of your function names. Now when I go into debugger, just by the function names, I know where to put breakpoints and start checking things. As the developer, as the programmer, always try to think like a hacker. Well, you know, I started hacking, as I said, 40 years ago. It's actually how I got involved in the Korean internet. When I was in Pohang, I came to Pohang in 1991. The internet in Korea had a lot of problems, but there were no companies, there was no one to manage that. It was all managed by some students or the Johnson Center staff who didn't know what they're doing. So I actually started hacking machines to fix them. If you talk to the old internet guys from the early 90s, you know, my nickname was 비밀관리자. and because I would go in, you know, hack root into the system, fix the problem, leave a note for the admin, make a new backdoor for myself, and close the old backdoor. I did that for years. And from Pohang, I was able to control the entire internet in Korea. For some years. The hacking tools, at least I have some familiarity with that. So I always consider when you're programming defensively, when you're programming for security, you have to know how the hacker will attack you. So if you don't know, find a friend who's a hacker to help you. Seriously, that you need to think that way.